Hi all. See this, in this particular problem we are going to find out a volume of a parallelepiped, right, where where the sides of this parallelogram or the parallelepiped or the cuboid, whatever you call, is actually given by that vectors, right? So therefore you have to find first the volume, right, and then we need to maximize it. So let's go ahead and see that. Let V be the volume. So therefore the V will be expressed as the determinant, that scalar product of these three vector, or in other way like down the determinant 1 lambda, and we have K component, that's 1. Then we have I component is 0, J component 1. For the second vector it is lambda, and it is lambda 0, 1. So this is the determinant, right? So volume of that parallelepiped, when the vectors are given, we have to write down the ij component, or it represent the scalar product of that, right? That's it. Now, whenever we have the determinant, right, our job is to expand it. Why we think care of that? So first we expand that. So if I expand the determinant, it will be 1 multiplied by 1 minus 0 minus lambda. It gives me that 0 minus lambda square, and plus 1 will expand it as 0 minus lambda. That's it. So if I write down that in a proper form, we'll say that it's lambda cube minus lambda plus 1. Okay, so that's the volume. We just rearrange the term. Okay, that's it. So we'll get is lambda cube minus lambda plus 1. That's the volume. Now what we want to find? We want to find the maximum or minimum volume. So therefore we'll differentiate and get it done, right? So therefore let's consider that V, right? So therefore if I differentiate, we'll get V dash. That gives me that 3 lambda square minus lambda. And if I calculate V double dash, that gives me that 6 lambda. Okay, that's it. Now for critical point, we consider V dash is equal to 0. That's imply that 3 lambda square minus 1 is equal to 0. That's imply that lambda is equal to plus minus 1 by root 3. And also see that V double dash at 1 by root 3, it's actually 6 1 by root 3, whatever maybe, it's greater than 0. So the volume will be minimum for lambda is equal to plus 1 by root 3. And see that here it says that find the value of lambda when it is minimum. So that's why obviously for this particular problem, option B is the right choice. So that's it. You can see that only the application of little bit of vector knowledge and the basic derivative, right, we are able to solve this problem. And that's it. Hope you understood it. Thank you.